Hi and welcome to video 4 on the Boolean Logic, Boolean Algebra and Circuits playlist. We're going to dive straight in with some worked examples, guys, but if you haven't had an opportunity to go through the rules, the Boolean Algebra rules in class, or you feel you need to revise them further, please do go through video 3 in the playlist, where I go through all of the Boolean Algebra rules in detail and give you a little bit of background information and set some expectations about what you need to learn and be prepared for your exam. So let's do our first example then. Let's say that we've been given A and B, and then that's ORed with A and negative or not B. So in this particular example, guys, we don't have any brackets to work with initially. Where do we start? Well, a really good place to start in a type of expression like this is to look for common terms so that you can factorize in order to make our expression simpler. This is something you've been doing in maths for a while, is to look for an opportunity to take a common term out of the expression and then use brackets to simplify. So if we look at our expression here, you can see that our common term is A. So I'm going to take A out of the brackets. I'm going to have A, and then that's going to be ANDed with, and then we're going to have B or negative B. Let's just check that's the case. Okay, if I look to expand my brackets, I will have A and B, which is what I've got here, and I will have A and not B, which is what I have here. So straight away you can see, if I just mark this here, that this is an instance where we can use our general OR rules, because we have a variable ORed with a negative of the same variable. So if you look at the help sheet, if you need to have a look at the help sheet, or guys, hopefully you will have learnt these off by heart, you will know that when we've got a variable ORed with the negative of itself, that is equivalent to 1. So I'm just going to write down here a 1. That then gives me, if I just put a line underneath and drop that down as well, that then gives me A and with 1. And A and with 1, again, this is an example of where we can use our general rules. In this case, it's our AND rules, and A ANDed with 1 will always give us the variable that we've ANDed with 1, which is simply A. So I'm just going to pop in, okay, the equivalent symbol, which I should have used earlier, but I didn't. So that is equivalent to A. Excuse me, guys. So our final answer is A and B, ORed with A and not B, is logically equivalent to A. So you will have noticed, guys, that I've used this little technique where I've drawn a line underneath the terms that I'm working with, and I've popped a little line down as well. In fact, what would also be an idea is just to pop a little arrow in, and this is to help the examiner understand which part of the expression is relevant to the particular working out that you're doing. So it's very clear here that we've taken this expression, and the result of evaluating this particular expression and using our Boolean rules is a 1, and it's very clear here that we've just dropped down this term here to give us the A, pop them together, and then of course we can do our further step. What you also might want to do is to pop in here the name of the rule that you've applied. You don't have to do this, but I've seen students do it, and it can make a big difference to helping somebody that's marking your work, particularly an examiner in your exams, understand how it is that you've got from here to here. And in this case, I would pop in there the OR logic rule, okay, or the OR general rule, and that just helps to clarify which step you're working on, okay, and where is the result of you working on that particular expression. We'll talk more about exam techniques in a separate video, but I just wanted to explain what it is that I'm doing here with these lines and these little drop downs. So let's do another example. This time we have negative, and then we've got A and B ANDed with negative A or B ANDed with, and then we've got negative B or B. So this is our starting expression that we need to simplify. We should really put on here is logically equivalent to a variable. Guys, can you see an opportunity here to use any of our 8 Boolean algebra rules? I think I might have given the game away because I've been pointing at it with my pen. You should have spotted, however, that this is a great opportunity to use one of our 4 OR logic rules. We've got negative B ORed with B, and if you check out the help sheet, if you're not sure what that's going to give us, essentially when we take negative B and OR it with B, we are going to get a 1. And in fact, I'm going to write down here logical. Let's put down here OR logical. So we're going to give ourselves a 1. So the next step of our working out is going to be to drop these terms down. So let's drop these terms down. I'm going to have the same as I had before. Negative A or B. And on this occasion, then we're going to be ANDing it with a 1. So what do we do with this? Well, again, a great opportunity to use our general rules. We've got an expression. If we take all of this expression ANDed with 1. In fact, this is a really good example of where we can take an entire expression or set of terms and AND it with 1, not just a single variable. So we can apply the same general logic rule with an entire set of terms or expressions, not just a single variable. So if we take anything and AND it with 1, we're essentially going to end up with our starting term, our term on the left. So here I'm going to underline all of the terms that I'm working with. Okay, and I'm going to put in here AND logic rule, because that's essentially what I'm working with, and this is going to evaluate as essentially the same expression that we've got above, ANDed with negative A or B, and essentially this term, this third term that we had to start with, has essentially disappeared, which is all good news. So can we now see an opportunity to simplify this further? Well, you may have spotted that this term here we can apply De Morgan's to, because we have a negative outside a bracket with a set of terms inside a set of variables. This is going to give us, we need to be really careful here to flip the operator. Okay, so we're going to get minus A and we're going to get minus B. We just need to remember that this changes from an AND to an OR. There we go, so I'm going to pop those in brackets. And then of course this expression remains the same for the time being, so we're going to end up with negative A or B. So what can we do now? Well, we are limited with our choice. Nothing jumps out at us, but it is an opportunity to look for common terms that we can factorize, and we do have a common term. We've got negative A, common to both, so I can take negative A out. In fact, I'm going to write distribution here, because what we're actually doing is we're taking the distribution rule or the distribution law and we're applying it in reverse. We're actually going backwards. We're taking our factored out expressions and we're factorizing back to what we would recognize as the distribution law. So I'm going to take negative A out, because that's a term that's common to our two expressions here in the brackets. We're going to end up with, we should have an OR there, and we're going to have negative B ANDed with B, essentially. Let's just check that this is correct. I'm going to pretend that I'm going to factor this out. Okay, and let's see what we get. So you should have A applied to B, so sorry, negative A applied to negative B, and it's an OR operator, and in this bracket I've got negative A or negative B, so that's correct. And applying A to our final term in the brackets, we've got negative A ORed with B, and we've got negative A ORed with B, and of course our principal operator is the AND, which is what we've got there, so that's good. Okay, so we've got negative A and then we've got ORed with the expression in the brackets. And again, guys, you can see an opportunity here to use our general rules for AND logic. So I'm going to put in here AND logic rule, and check out again, guys, on the help sheet if you're not sure what we're going to get with this. But if we take negative b anding it with b, we're essentially going to end up with 0. So I'm going to drop that down to make it a 0. This I'm just going to drop down on its own. So I'm now going to get negative. I'm just going to move this up a bit, guys, so you can see it more clearly. There we go. So I'm going to get negative a ORed with 0, and again an opportunity to use one of our 4 OR general rules. If we take negative a and OR it with 0, we are going to simply get negative a. So with all of these ones where we're applying our general rules, guys, check out the help sheet if you're not sure what I'm doing to evaluate these expressions. So this is where basically we've got as far as we can go. Doesn't get any simpler than negative a. So I'm just going to wrap up this question by putting down our final expression. Let me just move it up again. There we go. Just going to put down our starting expression and then our simplified form. So we started off with negative a b ANDed with negative a or b ANDed with, this is our start expression, negative b or b. We can say that that is logically equivalent to just negative a. So that would be our final answer that we will pop down. This is our working out essentially. This is our final answer, is to put our start expression and then pop in there our equivalence sign and just to put down our final answer on the end there. Okay, let's do another one. We have Q is logically equivalent, and then we've got A and B, or A and B or C, and then we've got ORed with, and then we've got B and B or C. Now, interestingly enough, guys, in this format, okay, this is exactly as the question was presented in the exam. Can you notice that A and B doesn't have brackets around? Which actually means that this particular set of terms, this expression, doesn't have to be evaluated on its own, okay, because brackets around this meaning that this term has to be evaluated as an AND gate, for example, before anything else happens. That isn't the case. No brackets around these two. So in essence, A and B, okay, we could actually move this expression around if we needed to a little bit later on. In contrast, B or C is in brackets because the output of that particular logic has then to be ANDed with A. So these two do have specific sets of brackets in. Okay, so that aside for the moment, can you guys see an opportunity for us to use one of our rules? The one that jumps out at me is this one, because this is going to be an example of our distribution rule. I'll just put dist down for the moment, because we've got terms in the bracket and we've got opposites. We've got an AND outside the bracket and an OR inside the bracket. That is one of the most important rules for the distribution rule to be applied. We've got to have these signs opposite. But in addition to that, we have the special case of the distribution rule, because our variable outside the bracket is also duplicated inside the bracket, which means that this actually is an example of the absorption rule. Now, I didn't actually choose this one to make a point that I was making earlier in the video when I said you don't want to be deriving rules which you could otherwise learn. Because we know that this is an absorption rule, this will actually simplify to simply the common term that we've got here. So that will be simplified to B. And because we know that this is the absorption rule, rather than having to derive this, which you don't want to do in an exam because it's a proof in its own right, we can simply say that this is the absorption rule, and then we can move on and look at our other terms. So what can we do? We've got B here, which is cool. What can we do here? Well, this is again an example of the distribution rule, but if you look carefully, if I expanded these brackets, I would then have A and B, and then I would have A and the C. If I end up with A and B, if I expand these two, I'm going to get the same term as I've got here, which is an opportunity to identify like terms, which I'm very keen on because that normally works really, really well. So I'm actually going to expand this term here. So we're going to end up with, okay, this stays the same. So we're going to end up with A and B here. And then we're going to end up with A and B. Okay, or A and C. There we go. So now you can see that we've got two identical terms and there's an OR logic in between them. So this is going to be a great opportunity again to apply our general OR logic. So I'm going to put that down here. As you would have seen in the last example, guys, we don't just have to work with single variables, we can work with expressions to use the general OR and AND rules. So the general OR rule, okay, we've got one expression ORed with another expression. If you have a look, check out the help sheet, you'll see that when we've got two expressions that or two variables the same, when we OR them together, we end up with just one of these expressions. So this is going to simplify to simply one example of A and B. Okay, we've got this one on the end here, so this is going to drop down to OR A and C, and then of course here we've got B, which I'm going to drop down here. So our next step in the working is to work with this expression here. We've got A and B, or A and C, or B. Now, because we've got no brackets around these, I can move my terms around. If you remember, that's one of the examples of the rules. Which rule was it, guys? Can you remember where we can move the terms around? Okay, actually the commutation rule. So I'm going to move the B over here because I've got two like terms. This is going to become, okay, A and B, and then or C, or A and C. So A and B. Okay, so I took a jump there actually, because essentially where I was going to with this was to say that B or B, B or B there, okay, if we commute our terms around, simply gives us the B, which is what we have here. But I've actually written that as a C, so that should be a B, that's why. There we go. So we've got A and B or B, or A and C. These two, essentially, two like variables ordered together will simply give us one of those, which is going to be the B. So we will now end up with, I can write in there for 1 to 2 or on the end. Okay, let's put it in there, OR logic rule, because I've just applied that. So I've done a bit of commutation. I've moved one of my variables around because we don't have any groupings here to restrict that. So I've got A and B or B, or A and C, and I've basically used my logic rule to whittle that down to 1B. Okay, so we've got these terms remaining. So I now have A and B, okay, or A and C. So what can I do with these two expressions? Well, what I could do is I could bracket these. Remember, I'm allowed to do that. Okay, I can group with the brackets, doesn't really matter. Okay, it's going to be convenient for me because once I've grouped them now on either side of the OR operator, I can take out the common term, and our common term again is the A. So if we take the A out, I am going to get A, and then I'm going to get ANDed with B or C. Let's just check that. So I'm going to have A applied to B, so that gives me A and B, which is there. A applied to C, which gives me A and C there, and of course we've got the OR operator in the middle. So this essentially is as simple as I'm going to be able to reduce my original expression. So let me just move this up, guys. There we go. So finally I'm going to say Q is logically equivalent to A and B, or A and then we had B or C, or and then we had B and B or C, okay, is logically equivalent to A and B or C. So that's our simplest form that we have on the right hand side. Okay guys, so we're going to look at quite a challenging example now, and the reason that I've put this one down as an example for us to go through is to show you that it's perfectly acceptable to be expanding brackets if we need to, expanding terms, so that we end up with a potentially longer expression than the one that we had to start with, specifically so that we can start to identify some of our Boolean algebra rules which we can apply. So this is slightly beyond A level, but nevertheless I wanted to go through this with you, I guess a little bit as a confidence booster as well, to let you know that it is acceptable and quite normal in order to end up with lots of expanded terms. So let's go through this, and I can show you how this one sort of pans out logically. So the question posed is, what is a simplified form of? And then we start off with, in brackets we have a and then we have negative b or c, okay, and that's anded with, and then we have a or negative b anded with c. So if you look at this, there's nothing here which jumps out at us straight away as an opportunity to apply any of our Boolean algebra rules. What we do have, however, which is useful for us, is AND logic here, because when we've got AND logic and terms either side, it means that if the worst comes to worst, we can start expanding out our terms, and then look for, once these are expanded out, look for opportunities where the rules become, the Boolean algebra rules become a little bit more obvious. So when we've got, just like in maths guys, when you've got terms in brackets multiplied, then you have to essentially apply each of the terms in turn. So essentially with something like this, we will end up with 4 terms. Okay, so at the moment we've got 2 ands, and I don't really want 2 ands, just the one will suffice. So I'm going to tidy up this right hand side, okay, and I'm going to expand this term here. So essentially it's the distribution rule that we are applying here. Okay, but we're doing it specifically to expand our terms. So what we're going to end up with here, if I just pop a bracket around there, because I'm going to group these together as well. So I'm just going to expand these sets of terms. So on the left hand side, I'm just going to drop this down for the moment because I'm just going to focus on this side. So this I'm going to leave as is. So A and, okay, negative B or C, and I'm just going to tidy this up with some brackets on this side like this, okay, and then we're going to have anded with whatever this beast turns out to be on the right hand side. So let's do it with do it in turn. So we got C applied to B, and then we will apply a C to the A on the other side, just like we do if we've got the distribution rule. So we're going to end up with C and A, okay, that's our first term, and then ORed with, and then we're going to have C and not B. Okay, now this looks a lot neater now because I've got a single and then I've got 2 terms on either side, so it's nice and balanced. So what that means now is I can apply this term to this one, and then of course to that one, just as you guys do, and then C to that term, and then C to that term. So we're going to do each of these in turn, and what we're going to end up with now is, on the left hand side we're going to have A and then negative B and C and A. Just need to be careful that I don't miss any of my terms writing these down. Okay, and then we're going to have ORed with, and then we do the same thing again, apply our A and not B to the other side of our bracket, so we'll end up with A and then we've got negative B and C and negative B. So you've got a negative B on either side there, so you've now got 2 negative B's. That's good news, because there's going to be an opportunity to apply some of our AND logic, general logic rules here. So things are shaping up already, although you might not believe so at the moment. So then we've got, okay, ORed with, and then on the right hand side from the C, we can have 2 lots of C for each of these because we've got a C and a C. So again, looks like we can have an opportunity to apply now more of our general logic rules. So we're going to end up with C and A. Okay, that's one term, and then we're going to end up with C and not B at the end there. Okay, Right, let's look for opportunities where we can apply our general rules. So you can see here I've got an A and an A. So essentially when I've got an A and an A, guys, if you check this out on your help sheet, okay, when I've got an A ANDed with another A, that just simply gives me a single A. So I'm going to evaluate this. I'm going to simplify this a little bit further. Essentially this is just going to give us A and negative B and C. Okay, so my two expressions A and A will just simply evaluate to a single A. Alright, so that's my first one. Okay, let's look for the same opportunity here. I've got a negative B and a negative B, so the same thing applies there with our general rules. When I've got one variable and another variable, that's the same as just giving me the variable. So that's A and I'm just going to have one negative B and C on that side. Now I've got the same thing here. I've got a C and a C, so that's just going to cancel out one of those C's and just give me a single C. So I'm going to have C and A. Okay, and then I'm going same on this side, guys. I've got two C's, which will give me C and C, just evaluates to the C. So C and then I've got my negative B. Okay, I'm sure you spotted this already, because now we've got two identical terms with an OR in the middle, here and here. So this would be exactly the same as X or X, which gives me X. So I'm going to take one of these expressions and drop it down. Okay, because applying my OR general rule, I get one of these terms when I OR them together. So this is going to give me just A and, okay, negative B and C. So just get one of these now, which is great. We've gone a long way. And then we've got, okay, ORed with C and A, ORed with C and not B. Okay, so you'll notice here that we do have, because I'm always looking for common terms, we do have a common term here. It's just that in here the negative B and C are the other way around. Okay, and if you remember from the commutation rule, it doesn't matter which way around these are, these two are the same. So I've got a common expression here, and I've got the same expression here. This is my common expression, which I'm going to take out to simplify. So just going to move these two terms in brackets around just to make it a little easier to see. So if I do that, I'm going to have A and negative B and C, and I'm just going to pop this one up here. So I've got OR C and negative B, okay, which is basically the same as this one here. So I just moved my common expression up, and then I've got C and A. I've just pushed this one over here a little bit because it's not going to form part of my next step, which is to work these two together, because I've got this common term. So if I'm just focusing on these two at the moment, I'm going to leave this one till later. If I take out the B and C, we'll just move this up, guys. Okay. If I take out the B and C, what I'm actually going to be left with is negative B and C, and then in the brackets I'm going to actually have A and 1. Okay, in the brackets. Let's have a look at that, because I'm going to have negative B and C and A, which is there. Okay, and then I just want to make sure I've covered this expression as well. That should be an OR, shouldn't it? So, okay, that's the AND, and that should be an OR. Okay, so B, negative B and C, okay, and then ANDed with the A gives me that expression, and then negative B and C, okay, ANDed with the 1 gives me C, the negative C and B, and then of course I've got the V in the middle. So I need to have the 1 in there to make sure I get this, these sets of terms back if I expanded these brackets, okay? And then over here I've got the C and A, which I'm leaving for the moment. Okay, so what do I get if I have A ORed with 1? Well, if I get A ORed with 1, if we have a look at the sheets, guys, an A ORed with 1, because I've just forgotten myself, an A ORed with 1 gives me a 1. Okay, so I get a negative B and C, okay, and that's going to be in here. I'm just going to have the 1, okay, and here I'm going to have the C and the A on this side. Alright, so just focusing on this bit, I'm simply here, this is going to evaluate 2 at the bottom. I'm simply with the 1, I'm simply going to get negative b and c, okay, and then ORed with c and a. And that in essence is about as simple as you're going to get it. Okay, now you can actually take out the c because c is common to both. We could do that if we wanted to as well. But this is a perfectly acceptable final form from our original expression at the top here. Just move that out of the way. So just to wrap this up, I'm just going to turn my piece of paper over because I've run out of space, because what we really ought to do is just to wrap this up with a final statement, which basically says that our original expression, okay, so original expression was a, and then we had not b, and then ORed with c, and then we had a, and then ORed with not b, okay, and then ANDed with c. That is going to be, okay, logically equivalent to our final expression, which I just popped earlier on the bottom of the paper, which was negative a and c, or, okay, c and a. And as I say, guys, you could take the c out if you wanted to, but that form there is a perfectly acceptable final form given this initial expression here. Okay guys, here's a nice, well, simpler one to wrap up. So you have a or b, and then ANDed with b or not a. And again, it's one of those examples where nothing really strikes us as being useful at the moment for our Boolean rules we can apply. So we're going to want to expand the terms. Okay, we're going to want to expand the brackets and see what we get then. So let's take each item in turn, our a and our b, and our a and our a, and our b and a b, and our b and our not a. So we're going to start off with then a. Do the a first. We're going to end up with a and this b here. Okay, and then that's going to be ORed with. And then we're going to do a and not a, so we're going to get a and not a. Okay, and then that's going to be ORed with. And we've got b and b, okay, from here. And then we've got ORed with, and then we've got b and not a. Okay, so now we've got examples where we can apply our general logic rules, our AND and our OR if we need to. This one's going to be our AND, where we've got b ANDed with b, and that is going to give us just a single b. And we have an example where we've got a ANDed with not a, and that's going to give us 0. That's one of our 4 AND logic rules. Okay, so then we're going to have a and b, ORed with 0, ORed with b, ORed with b and not a. Nothing we can do with these at the moment. However, when we have 0 ORed with anything, essentially the 0 is irrelevant, it doesn't do anything, so you can essentially eliminate the 0 there. So I'm going to have a and b, okay, and then ORed with b, ORed with, and then b and negative a. Okay, so here we have now an example of one of the rules which we could apply, which is the absorption rule, because we have 2 signs which are the opposite. We've got an AND inside the brackets and an OR outside the brackets. That's a tick in the box for applying our absorption rule. And then we have a variable which is common to the outside and inside. The b is outside the bracket and it appears inside the bracket as well. So this is simply going to evaluate as b, evaluates to the common variable which is b, okay, or, and then we're going to have b and negative a. And again, here's an example of our absorption rule. We have a b on the outside, we've got a b on the inside, we've got 2 opposite signs So this will essentially evaluate to B as well. So in other words, A or B ANDed with B or not A is logically equivalent to, quite simply, B. Okay. Right guys, so that brings me to the end of the worked examples. I hope the video has been useful. More in class, more in the worksheets. Do let me know if you want additional help with anything that you've seen in the video or with these Boolean algebra questions in general. In the next video we will be moving on to an introduction to Carnot maps. I will see you in the next video.